Okay, graphing quadratics. Mostly reviews. Hopefully this will all make sense. Let's talk about x-intercepts for a little bit. We haven't really done that yet. There are ways that you can see how many intercepts that a quadratic has, and it comes from this thing over here, which is called the discriminant. And that should ring a bell, because that probably has something to do with the negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay. Okay, how does this determine the intercepts? Well, let's say that we have a number larger than 0, so for example 7, and I'll just pick another couple numbers there, and let's say if a is 1, we get 2 here. Well, you can see that if you have a number larger than 0, you get a square root, so there are going to be two answers here. You will get a negative 1 plus the square root of 7 divided by 2, that's one intercept, and a negative 1 minus the square root of 7 divided by 2. So, discriminant larger than 0 will carry two distinct x-intercepts. If the discriminant equals 0, you would get a negative 1 plus or minus the square root of 0 divided by 2. Well, the square root of 0 is 0, so you end up with a negative half, and that's why you only get one x-intercept. If it's less than 0, a negative 1 plus or minus the square root of a negative 7 divided by 2, well, that's an imaginary number. They're sort of difficult to graph, and that's why you would not have an x-intercept. Okay? You can find intercepts by, you can solve for 0, either factoring, completing the square, or the quadratic formula. Here are the pictures, actually, that go with the three situations that I just went through. So, greater than 0, you get a picture that looks like this, provided that a is larger than 0, so we need something that goes up. 1, and no x-intercepts. Okay? I do want to show you something real quick over here. Let's see if I can find the right function. So, okay, if this is in vertex form, you can clearly see the vertex would be at a negative 3, negative 8, and we do know that it's going up a little faster than normal, but the x-intercepts are not easy to see. Well, you can still solve for them. So solving for them would just mean this. Now you can distribute this out, work your way all the way through it, and then see what happens, but I don't want you to forget about the fact that you can move the 8 this way. You can divide by 2 on both sides. And then, sorry, you need to divide by 2 then. 8 divided by 2 is 4. And then take the square root to get rid of the square. So it will be x plus 3 equal to the square root of 4. Don't forget plus or minus. Okay, when you take a square root, you always need a plus or minus. And then you get the following. Take away 3 on both sides. And the square root of 4 is 2. So two x-intercepts, a negative 3 plus 2, which is a negative 1, and a negative 3 minus 2, which is a negative 5. Okay? Completing the square, it's a really good way to solve for x-intercepts if you're in vertex form. Alright, so let's do one without vertex form. So graph it by finding the vertex. Negative b over 2a. So that's a negative 6 divided by 2. So the vertex happens at a negative 3. What value do you get? Well, that's 9 minus 18 plus 8. That's a negative 10, and then 9. So f negative 3, I think, is a negative 1. So negative 3, negative 1 is on my graph. So that would be here. What else do I need to find? The intercepts. Okay, so intercepts x squared plus 6x plus 8 is 0. It factors. So the intercepts occur at a negative 4 and a negative 2, at least the x ones. Negative 4, negative 2. The y-intercepts would be found by plugging in 0, so you get 0 plus 0 plus 8, that's 8. And you do have symmetry through this line. So if you are 1, 2, 3 away, you are 1, 2, 3 away over here. And that's enough. I know there's a point missing in here, but that's not a huge deal. And there's my not so great graph, but pretty good. Okay. Where's the function increasing and decreasing? So if it opens up, then it's increasing from, decreasing from a negative infinity to the x coordinate here was a negative 3, right? to -3, so it's decreasing, and then increasing from a -3 until infinity. What else? Determine the domain and range. Domain is all real numbers. So that's the domain. And the range, well, it starts at, need a square bracket. It starts with a y value of -1 and then goes up to infinity, which is a round bracket. So that's the range. Somehow I messed up my, okay, that should be B and that should be C. And then the last question says, complete the square and right equation in vertex form. So, x squared plus 6x plus 8, that becomes x plus 3 squared plus 8. The 3, when you multiply this out, gives me an extra 9, so I need to subtract that. So in vertex form, I would get x plus 3 squared. 8 minus 9 is a -1. Let's see, -3, -1 is my vertex. So yep, so that looks like it worked. Okay, well, that's pretty much it. It's fairly fast. Here's some more information. Oh, no, there's one more question. So here's some more information about, most of this we saw already in the other notes. We see the vertex again and plugging it in, axis of symmetry. You know, if it's in vertex form, I would complete the square, and then you could graph it with transformations. And if you don't have it in vertex form, then I guess you're probably going to find the vertex and then work your way through it. So you have your choice. Okay. And then the last problem is sort of backwards one. So what if you know that the vertex is a -2, -5? Well, that's h and that's k. So that means we get f of x equals a x minus h, so the answer being +2, plus k, and k is a -5 in this case. We do need a square here. Okay, so I'm going to clean that up a little bit, and then I need to use that last piece of information. It says the y-intercept is a -1, so that means that the point 0, -1 is on the graph. That's an x, that's a y, plug them in, and that should allow you to find a. So 0, so -1 is equal to 2 squared is 4, so this is 4a minus 5. Move this one across, plus 5. You get 4 is equal to 4a, so a equals 1. So finally you get 1 for a, so you can leave it x plus 2 squared minus 5. Thanks.